Welcome guys to video on HCF part 3. HCF means highest common factor and or it is also referred to as greatest common divisor. Please refer earlier videos part 1 and part 2 where I have described what do you mean by factors, multiples and how do you find HCF and LCM. In this video, we will understand for which word problems or numericals we use HCF. So let's get started. HCF. When to use HCF or GCD? When we want to reduce the fraction to its lowest form. For example, say 348 and 319. We are supposed to reduce this fraction to its lowest form. How do you do it? What we do basically is we find the HCF of these numbers, that is 348 and 319 separately. Okay, so let's start with 348. 348 is an even number, so we can start with 2. It becomes easy. 2 times 174. Again 174 is an even number, so we can continue with 2. 2 times 87 is 174. Now 87 is an odd number. We can think of 3. So 3 times 29 is 87 and 29 is a prime number. So 29 times 1. So all these are factors of 348. So let's write down here. Right. Now next is 319. We need to find the factors of 319. This goes in 11. 11 times 29. Now 29 is a prime number, so we'll take 29 as it is. 29 times 1. So factors of 319 are 11 and 29. So we'll write down here. Now the highest common factor. What are the factors that are common to both the numbers? So it is only 29 that we have common in both the numbers. So HCF of these two numbers is 29. Now what we do is we divide this fraction, the numerator and denominator, separately by 29. So like this. So 348 divided by the HCF, that is 29, and 319 divided by the HCF, that is 29. So this comes to 12 upon 11. So now we have reduced 348 upon 319 to its lowest form, that is 12 upon 11. So finding HCF and dividing the numerator and the denominator by the HCF will reduce the given fraction to its lowest form. So this is where we use HCF, or this is where we can use HCF. So basically when we want to reduce the fraction to its lowest form, we find HCF and then we divide the numerator and the denominator separately by the HCF and get the lowest form. Next, where do we use this HCF or GCD? When we have word problems where we need to find the greatest common divisor. Let's consider an example. So here we have 3 different containers containing 496 liters, 403 liters and 713 liters of milk. What biggest measure can measure all different quantities exactly? We need to find a measure this cans like this, a measuring can like this, which will measure the given milk exactly, so that the can doesn't is not half filled or 3/4 filled. It should be completely filled. So if we need to consider a can which will be completely filled and it will measure all these numbers exactly, so that is what we are supposed to find. So how do we proceed? Once again here what do we do is we find the HCF of these given numbers. So 496, we'll start with 2. 2 times 248, then 2 times 124, then 2 times 62, 2 times 31, and then 31 is a prime number, so 31 times 1. So factors of 496 will write down them like this. Now next is 403. So we need to find the factors of 403, that is we'll start with 13. 13 times 31 and then 31 is a prime number, so 31 times 1. So factors of 403 are 13 and 31. Now next is 713. So again here we start with 31. times 23 is 713, and then 23 is a prime number, so 23 times 1. So we'll write down here. Basically, when we have big numbers like this, 496, 400, 713, numbers which are big, for such numbers it is always advisable to find their factors separately instead of finding them simultaneously. Like I could have done 96, 403 and 713. This method I have discussed in my part 2 video, but this is applicable or is feasible when these numbers are small. Now because these numbers are big, it becomes difficult for us to remember the tables. So it's always advisable for bigger numbers to find their factors separately, so that what happens is you get a brief idea which would be the common number to all. Like in this case 31. So you can think of 31 times 403 somewhere. Here also 713, 13 times 31 times some number. Okay, so it gives us a quick idea which could be a common divisor. So it's for bigger numbers, it's always advisable to find their factors separately. Now here you can see the common factor for all the three numbers is 31, right? So HCF of these three numbers is 31. What does that mean? It means that this 31 liters is the biggest measure that can measure all the different quantities exactly. So we need to have a 31 liters can which will measure this as well as this exactly. There won't be any remainder of milk in the container. Hope it is clear. Now let's see another example. Find the greatest number which divides 253, 568, 813 and leaves the same remainder in each time. HCF, if you remember, HCF means we are supposed to find the divisor, the denominator. Okay, so find the greatest number which divides. Okay, so we have this 253, 568, 813. So we need a greatest number, the divisor, which will divide this and leave the same remainder each time. So in such cases, what we have to do when we have a remainder left, a different method is used. You need to remember this. What we do is we find differences between the given numbers, and then we will have a new set of numbers, and then we find the HCF of this new set of numbers. Okay, let's see what I mean here. So now here these are three numbers. So what we do is we subtract 253 from 568, then we subtract 568 from 813 and 253 from 813. So like this we get now three different numbers. Now these numbers 315, 245 and 560, we find HCF of these numbers. Okay, so let's find HCF of these numbers. Here I have done it simultaneously because it is ending with 5 and 0. So obviously we can think of 5. So 5 times 63, 5 times 49 and 5 times 112. Now here 63, 49 we know it goes in 7. So we can think of 7. 7 times 9 is 63, 7 times 7 is 49 and 7 times 16 is 112. Now these won't be going in the same number. So the HCF of these three numbers is 35. 5 times 7 is 35. So now what it means is that 35 is the greatest number that will divide the given set of numbers, this, and will leave the same remainder. That means if you divide 253 by 35, 568 by 35 and 813 by 35, you will get the same remainder. Do try for yourself. You will see you will have the same remainder in each case. But remember the method, when they have said कि it leaves the same remainder, in that case we need to do subtraction and have new set of numbers and then find the HCF of these new set of numbers, and the HCF that we get is the required number which will divide the given numbers and will leave the same remainder. You can see for yourself, do try for yourself. Now let's consider another example. Find the greatest number which divides 1356, 1868 and 2764, leaving the same remainder 12 in each case. Now this is different. Earlier the remainder was not given, here the remainder is given. So what basically we do is we subtract this remainder from each of these numbers, get a new set of numbers and find the HCF of this new set of numbers. Okay, let's see. First is we subtract this remainder 12 that is given to us from each of this number, and then we get new set of numbers and then find the HCF of this new set of numbers. So 1356 minus 12 is 1344, then 1868 minus 12 is 1856, then 2764 minus 12 is 2752. Now we find HCF of these three numbers. Okay, so these are our new set of numbers. Now let's find the HCF. HCF you will get like this. Okay, now HCF is the highest common factor. So in this case, this 2 is common to all the numbers. Again we have 2 common to all the numbers. Again we have 2 common here. So here it is common and here. Now we don't have any other common number. So we have 2, 1, 2, 3, 4, 5, 6, right? So HCF is 2 into 2, 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 times 2 is 64. So basically HCF of these numbers is 64. So what it means is, so when these given set of numbers, that is 1356, 1868 and 2764 is divided by 64, we will obtain 12 as a remainder in each case. Okay, so basically we are finding divisor. HCF means we are finding the divisor. So hope it is clear. HCF you will use when you want to reduce the fraction to its lowest form, when you have to divide the given set of numbers leaving exactly the same remainder, and when you have to divide the given numbers and the remainder is given. Okay, a small difference is there. Here what you do, when the remainder is given, you subtract the remainder from each of these numbers, then you find the HCF, and that HCF is the divisor for these set of numbers which will leave the remainder 12 in each case. When the remainder is not given, then what you do is you just subtract the given numbers, smaller number from the bigger numbers and have new set of numbers and then find the HCF, and that becomes the divisor for the given set of numbers. Hope the concept is clear. In my next video, I am going to discuss when to use LCM. So do watch my next video. Also refer to my earlier videos. Till then, do like, share, subscribe the channel for more such videos. Thank you.